Good morning, students. Hope all you are safe. This is Max class. In the last class, we learned some theorems. So far, we have learned adjoint and how to find out inverse. Now, in this, if adj is given, how to find out A, and if adj is given, how to find out A inverse. This is the topic we are going to learn today. Say, A inverse formula we know, that is A inverse is equal to 1 by determinant A into adj. 1 by determinant A into adj. See, for 3 by 3 matrix, see, let me remind you first before taking that adj is equal to determinant A power n minus 1. Determinant A power n minus 1. In one theorem, one of the properties determinant at J is equal to determinant A power n minus 1. For 3 by 3 matrix, what it happens? The order will be 3. 3 minus 1 is 2. Determinant A square is equal to determinant at J. So, determinant A will be equal to plus or minus square root of determinant at J. This is only for 3 by 3 matrix. So, if we use this value in this A inverse, what happens? A inverse is equal to 1 by plus or minus root of determinant at J into at J. Determinant at J into at J. Also, we have learned that adj into adj is equal to determinant A into A for 3 by 3 matrix. The same, this in place of this determinant A, if we use this plus or minus square root of determinant at J, we will be getting A is equal to plus or minus 1 by square root of determinant at J into adj of adj. What is the meaning of adj of adj? For the adj, again we have to find out adjoint. Again, one more time we have to find out the adjoint. So, these two formulas we are going to use. When adj is given, how to find out A inverse. The same way when adj is given, how to find out A. Okay, shall we move to the problem? Okay, example 1.5. Find a matrix A if adj is equal to matrix 7, 7, minus 7, minus 1, 11, 7, 11, 5, 7. See, adj is given and they have asked to find out matrix A. Usually if adj is given, what is the formula? A is equal to plus or minus 1 by square root of determinant adj into adj of adj. So, we can keep it as equation number 1. So, what are the values we need? Determinant adj we need, the same way adj of adj. One by one we will find it out. First, determinant adj. So, that is determinant 7, 7, minus 7, minus 1, 11, 7, 11, 5, 7. Shall we simplify it? We all know to find out the determinant. See, 7 into leaving the corresponding row and column, determinant of these 4 values 2 by 2 matrix. 11 into 7, 77 minus the other diagonal 5 into 7. 5, 7 is 35. Then when we write the second value, we have to give the minus 7 into. Leave that row and column. These 4 values, minus 1 into 7, minus 7, minus 11 into 7, 77. The next value, when we give it is plus. See, but here the value is minus 7. So let me give it in bracket. Minus 7 into, leave that corresponding row and column. Minus 1 into 5. Minus 5 minus 11 into 11. 121. Now shall we simplify it? See, 7 into 77 minus 35. When we subtract, how much you will be getting? 42. Minus 7 into minus 7 minus 77. Both the numbers are negative. So what we should do? Add and put negative symbol. So minus 84. This is minus 7 into minus 126. Now shall we multiply? 7 into 42. 294. Now minus into minus plus. 7 into 84. 588. Again minus into plus, minus 7 into 126, 882. When we add, what we will get it? 4, 6, then 17. So this is greater than 0. We have got it 1764. So determinant at J we got it. Okay, square root value later we can find it out. Now we are supposed to find out adj of adj A. Yeah, see, adj of adj A. This is adj A given in the question. So put it big bracket. What is that? Plus, minus, plus. Second value minus, plus, minus. Third plus, minus, plus. Adjoint. That is, Aj, the whole transpose will be there. Okay, let me give the transpose. Shall we find out directly? For this position, leave that row and column. 11 into 7, 77, minus 5 into 7, 35. Okay, now for the second position, leave that row and column. Minus 1 into 7, minus 7, minus 77. For this position, leave that row and column. Minus 1 into 5, minus 5, minus 11 into 11, 121. Same way we should find it out for the second row. Minus 1. This position, leave that row and column. So these four values. 7 into 7, 49, minus 5 into minus 7. That is 5 into minus 7 is minus 35. Since here already minus is there, we will get it plus 35. Now for this position, leave that row and column. 7 into 7, 49, minus 11 into minus 7, minus 77. Since we have a minus here, this is plus 77. Now for this position, leave that row and column. 7 into 5, 35, minus 11 into 7, 77. For the last, leave that row and column. 7 into 7, 49, minus 11 into minus 7 is minus 77. Since we have a minus here, plus 77. This first position. 7 into 7, 49, minus 1 into 7 is plus 7. So here it is 7. Now 7 into 11, 77, minus 1 into 7 is minus 7. Since we have a minus here, this will become plus 7. Okay. Now, shall we simplify? See, this is 42. This minus 7, minus 77. This is minus of minus 84. This is minus 126. Here, 49 plus 35. We have a minus outside, so minus 84. 49 plus 77. 126 minus 35 minus 77. How much you will be getting? Subtract and put greater number symbol, minus 42. Here 49 plus 77, 126 minus 49 minus 7 is 42. This is 84 transpose. So one more. Since bracket is there, we will simplify it. What are the values? 42, 84, 100 and minus 126, minus 84, 126, minus into minus plus 42, 126, minus 42 and 84. Transpose. So transpose means what is the meaning? Row has to be written it as column. 42, 84 minus 126. Then this is minus 84, 126, 42. 126 minus 42, 84. So we have got it. Edge of edge A. Now equation 1 implies, what's the formula actually? A is equal to plus or minus 1 by square root of determinant at A. What value we got it? 1764 into edge of at A. The same value. 42 minus 84, 126. 84, 126 minus 42 minus 126, 42, 84. Is it not? Okay, first this. Since it is inside the square root, we have to find out the value. How to find it out? Shall we find it out here? 1764. How we have to find it out, ma? From the last, we have to separate two digits. Yeah, 64, 17. 17 square number, check it. 2 into 2, 4. 3 into 3, 9. 4 into 4, 16. 5 into 5, 25. So it is 25, but here it is less than 25, so I am giving 4 into 4, 16. So how much balance? 1. Take the next two digits, 64. Before multiplying, what we should do? This value we have to double it and write it. 4 into 2, 8. Now 8 into what value? If I give 1, here also I have to give. 81 into 1 is 81. But it is more than that. So shall we check it with 82? 82 into 2. 2 into 2, 4. 8 into 2, 16. So we have got the value. 82 into 2, 164. So the square root of the value is 42. So plus or minus 1 by 42. See here, these all multiples of 42. So shall we take a 42 outside? When we take a 42 outside, here 1 minus 2, 42 into 3 is 126. Here 2, 3 minus 1 minus 3, 2, sorry, this is 1 and here it is 2. So 42 and 42 will be getting cancelled. Our answer is plus or minus 1 minus 2, 3, 2, 3 minus 1 minus 3, 1, 2. So this is the procedure when edge A is given and A is asked. Do you all understood? Okay, I hope all you might have understood. Now we have to move to the next problem. If edge A is given, how to find out the inverse, A inverse. Shall we move to that? Example 1.6. If edge A is equal to matrix is given and they have asked us to find A inverse. Okay, shall we write the formula first? What is that? If edge A is given, plus or minus 1 by root of determinant edge A into edge A. This is very simple. 1 by square root of determinant edge A into edge A, because edge A is given for us. Now only we need to find out determinant edge A. Shall we find out? See, if we can keep it this as equation number 1. Determinant edge A is equal to determinant minus 1, 2, 2, 1, 1, 2, 2, 2, 1. Okay, shall we find it out? See, minus 1 into, leave that row and column. 1 into 1, 1 minus 2 into 2, 4. Second value when we write minus, is there 2. Leave that row and column. 1 into 1, 1 minus 2 into 2 is 4. Then plus, that is 2 into, leave that row and column. 1 into 2 is 2, minus again 2 into 1 is 2. Say minus 1 into 1 minus 4, that is minus 3. Minus 2 into 1 minus 4, minus 3. Plus 2 into 2 minus 2 is 0. See, minus into minus plus 1 into 3 is 3. Minus into minus plus 2 into 3 is 6. So, we will be getting 3 plus 6 is equal to 9. Now, we can substitute in equation 1. Equation 1 implies A inverse is equal to plus or minus 1 by root of determinant at GA. Just now we have got the answer. Root 9 into at GA. That's given question, isn't it? Minus 1, 2, 2, 1, 1, 2, 2, 2, 1. See, plus or minus 1 by root 9. We know the value. Root 9 is 3. Into minus 1, 2, 2, 1, 1, 2, 2, 2, 1. Here no number is common to take it out to divide by 3. So this is the answer for this. So today we have learned two questions. One is if RGA is given, how to find out A, and the next one is if RGA is given, how to find it out A inverse. Now the next problem, example on point 7. If A is symmetric, prove that RGA is symmetric. If A is symmetric, prove that RGA is symmetric. What is that symmetric means? We have learned. See, I am writing since A is symmetric, which implies A transpose is equal to A. Keep it as equation number 1. Symmetric, in 11th standard we might have learned. If you are not remembering, this is a condition that if A is symmetric, then A transpose is equal to A. Now, we are supposed to prove that RGA is symmetric. That means what is the meaning? RGA the whole transpose is equal to RGA. RGA the whole transpose is equal to RGA. This is what we need to prove. Say, from theorem 1.9, we have A transpose is equal to RGA the whole transpose. If you are checking the theorem, this is there. A transpose is equal to RGA the whole transpose. Now, using 1, what we can say? A transpose is equal to A, isn't it? So, which implies RGA is equal to, this is RGA the whole transpose. What we have used? Using equation number 1. Equation number 1 says that A transpose is equal to A. Now what we have got it? RGA is equal to RGA the whole transpose, which implies RGA is symmetric. Very simple. 2 mark question. RGA is symmetric. If A is symmetric, prove that RGA is symmetric. This also we have proved. Shall we move to the next problem? The next problem, example 1.8, verify the property A transpose the whole inverse is equal to A inverse the whole transpose with A is equal to matrix 2, 9, 1, 7. This is a 2 by 2 matrix, isn't it? See, first shall we find out the left hand side? A transpose the whole inverse. Anyway, first we need A transpose. What is that? A, I am writing 2, 9, 1, 7, the whole transpose. When we transpose, how much we will be getting? The row has to write as column. 2, 9, 1, 7. Okay, now I am going to write the inverse formula. A transpose the whole inverse is equal to, actually, A inverse, the formula is 1 by determinant A into HA. Is it not? Now A transpose the whole inverse means what will be there? 1 by determinant A transpose into H A transpose. For this transpose only we need to find out H. Now first we need to find it out whether this inverse exists or not. Shall we check it? For that we have to find out determinant A transpose. That is determinant A transpose. What is there? 2, 1, 9, 7. Find it out the determinant. 2 into 7. 14 minus 9 into 1 is 9. 14 minus 9, 5. We are very sure this is not equal to 0. Therefore, A transpose the whole inverse exists. Now, we need to find out H A transpose. See, H A transpose. If it is a 2 by 2 matrix, I have given a shortcut method. What is that? Change the main diagonal. So, we may get 7, 2. The other diagonal, same element, just we have to change the symbol. It's very simple, isn't it? Change the main diagonal. The other diagonals, simple alone, we need to change it. Or else you have to do using the direct formula method. Okay. Now I am going to write the formula again. A transpose the whole inverse is equal to 1 by determinant A transpose into H A transpose. So we may get 1 by determinant A transpose is 5 into 7 minus 1 minus 9 2. So I am going to take this as equation number 1. Right hand side we need to find it out A inverse the whole transpose. So first I have to find it out the determinant A for the second part. That is determinant 2, 9, 1, 7. Shall we find it out? Say 2 into 7, 14 minus 9. This also we are getting 5. This is not equal to 0. A inverse exists. So we are supposed to find out HA. HA, how to find it out? For 2 by 2 matrix, very simple, isn't it? 2, 7 means it will change it as 7, 2. This we have to change the symbol. Minus 9, minus 1. Now I can put it in the formula. A inverse is equal to 1 by determinant A into HA. So 1 by 5 into our HA is 7 minus 9 minus 1 2. So right hand side is A inverse the whole transpose. So 1 by 5 into 7 minus 9 minus 1 2 the whole transpose. So 1 by 5 into, transfer it ma, 7 minus 9 minus 1, 2. Now shall we take it as equation number 2? Yes. See, equation 1, the value is 1 by 5 into 7 minus 1 minus 9, 2. The same way equation 2 also says 1 by 5 into 7 minus 1 minus 9, 2. So what we will write it? From 1 and 2, what we have got it? A transpose the whole inverse is equal to A inverse the whole transpose. Is it correct? Okay. So suppose if you are unable to do this shortcut, do with the procedure. Okay. What will be that procedure? Okay, let me write it here. So first you have to find it out Aij. This is for transpose means A transpose for that Aij. What we will do? Plus, minus, minus, plus. Is it not? Plus, minus, minus, plus. So here leaving the row and column 7. This is leaving the row and column 9. For this position we may get that is 1. And for this position, leaving that row and column, that is 2. Now, HA transpose is equal to, what is that? Aij transpose, the whole transpose. So transfer it. 7 minus 9 minus 1, 2. You have got the same value, no? So if you are unable to do in this shortcut, do with our original formula procedure. Okay. So now this is our homework part. Exercise 1.1, problem number 7. If A is equal to matrix 3, 2, 7, 5 and B is equal to matrix minus 1, minus 3, 5, 2. Where for this we have to verify AB the whole inverse is equal to B inverse into A inverse. And the second, 8th problem is if at GA is equal to, at GA is given, find A. Today we have done this method. The 9th problem is if at GA is equal to, at GA is given, find A inverse. 10th one is find adj of at GA is given. Okay, I hope this 3 will be easy. This problem also, it's easy. For this AB inverse, we have to find out AB first, then find out the inverse of that. B inverse, find it out, A inverse, find it out, and then you multiply and check the answer. Okay, answers I have given here to verify. 8th problem A is equal to, and 9th problem A inverse, and 10th adj of at GA. Since 7th problem is verify, I have given at least the left hand side AB the whole inverse. You should get it 1 by 13 into minus 11 5 minus 18 7. Okay, complete these 4 problems. See, 7th problem we have an example also that I will be doing it in the next class. Since it is simple problem, since we know to find it out the inverse, I have given you this homework. Okay. If you have any doubt in these 4 problems, you can ask me in the interaction section on Wednesday afternoon. Thank you, students. See you in the next class. Bye-bye.